Hess's law is about theoretically, just review from yesterday, theoretically finding our delta H's. So chapter 9 was all about experimentally how to do it. Q equals MC delta T. And perhaps the heat transfer, so N delta H equals MC delta T. But that was all experiment, things you can do in an experiment. So this is theoretically how do you do it. If I can't do an experiment, for example, or actually if I just want to see theoretically predicting my work. Okay? So A and B goes to C and D. What if I cannot, I want to know this delta H, but I can't do it by experiment. So I can't do this reaction underneath a can, and then take the MC delta T of the can, and then solve for my delta H. Because it won't react. Or it won't produce those things, or something. It produces something else, or who knows. Hess says that we can go an alternate pathway. I can go this way, and I can form some other products. And then I can take those products and form my C and D. And if you indirectly do it, you can take your delta H1 and add that to delta H2, because one will be positive, one will be negative. So it's actually like subtracting. And I will end up with the value of delta H that's the same here. Get it?
Oh, God.
Oh, God, you're a little bit late. Next time I'm going to say no unless you go right away, Gabby. Yeah?
Yeah.
Okay, so Hess's law states that the energy of a whole reaction is equivalent to the sum of its steps. So for example, let's try this one. Carbon and oxygen react to give you a formation of carbon dioxide. Not a problem. But let's say we cannot undergo, okay, so we're trying to find the delta H of this. Okay, delta H equals, I don't know. Well, we can look up in the book, carbon and oxygen making carbon dioxide gives me this delta H. Okay, so I'm kind of halfway there. Do you see that? And carbon monoxide reacting with another oxygen can give me carbon dioxide. Got it? And that is this delta H. And so, Hess's law says that I can indirectly go, or I can add my two half reactions. No, not half reactions. I'm getting a little bit confused between the two theories. Not two theories, but the two views of the theory. Anyway, if I add these together, I should be able to result in a net delta H that's the same. Gabby, do you have a package?
No, I don't.
Did you get one yesterday? Okay, so, right. What do I have on, we did a little bit of this yesterday, okay? So, we add up our terms like they're algebra, left side, right side. Things that cancel out can cancel out, just like algebra. So, if this carbon is on the left-hand side, I can write it here as a product. And if this carbon monoxide is on the left-hand side, I can write that there as well. Not as a product. I've been thrown off by you, Gabby. I need to find my groove again. Okay, how many oxygens have I got on the left-hand side of my arrow? Here are my arrows. How many oxygens have I got? In total? 1. So 1, O2, or I'm just going to write O2 because then it looks like I've got 10 or something like that. Arrow, and I have a carbon monoxide and I have a carbon dioxide. Everybody okay with that? And what can you see if this was algebra and these were variables? What can you see is the same on the left and the right? CO. And so therefore they can cancel out like they do in algebra. And so what am I left with here? Carbon and oxygen giving me CO2. Is that what I wanted? Oh. And your delta H's should then also be added up. And so negative 100 and negative 200 make negative 389. Pardon me? 393. 393.5 kilojoules. Everybody okay with that? And so let's watch the pictures come down. I'm going to add them up because he says the sum of its steps. So adding up, carbon came down, carbon monoxide came down, a blue, half an oxygen, and a red, half an oxygen combined to make a purple oxygen. That's good. Carbon monoxide, carbon monoxide, carbon dioxide, one on each side, cancel out. What am I left with? The net reaction that I wanted. Carbon, oxygen, carbon dioxide, and the delta H value as is. If you're okay with that? That is as simple as it will ever be.
Yay.
Yeah, they don't. It doesn't stop there. Hess's law allows us to add equations. We add all products and reactants, and we add delta H values. Okay? We can also show these steps add together via an enthalpy diagram. Ready? You're going to write one. The enthalpy diagram for this would look like this. EP and time, that's a given, right? You okay with that? Mm-hmm. Okay. This reaction, what does it start with? Carbon and half an oxygen, and it forms exothermically, -110, forms carbon dioxide, or carbon monoxide, pardon me. Okay? Everybody okay with that enthalpy diagram for this? No problems, right? Easy. And then that carbon monoxide would react with another half an O2 and form carbon dioxide. And that would give me -283. Red. Gabby, you need to be writing that down. And so, what's the point? Well, going down this step and going down this step, this is what my son does. He doesn't like to go down every step. He likes to jump in our house from, well, as high as he can, really, not just 2 steps. He'll go
junior class change.
8 steps if I let him, but he's only 3, so I try to stick to just a couple steps. All the way down to here. And what do I have? Carbon and half an oxygen, giving me carbon dioxide. Oh, and another half an oxygen. And in total, that value should be 110 plus 283, which is equal to -393. Hey, look at that. So visually you can see how you can get how the sum of 2 steps equals the overall addition of both steps. Both symbol-wise, as in like formulas, and your delta H total. Do you see that? Get it? So if you can't go down the big step, you can take little steps to get there. That's what Hess's law is saying. And do you remember this is algebraically doing it, and then there's another way of doing it as well. That's like second half of this chapter. Okay? All right. That's as easy as it gets. They obviously are going to get more complicated. So here is a more complicated example. Let's say we want to see how much energy when you take iron and you react it with oxygen and you get, well, a form of rust, iron oxide, iron 3 oxide. Now, can you do that? Could you take a calorimeter? Could you do this experimentally? Could you take a pot of water and could you take a piece of iron and combust it? Does iron easily combust? Not really, right? So you have some problems here. So it's much better to do this one theoretically. Okay, so we find 2, or they give us, okay, in a question, they give you 2 reactions, like that. And 2 delta H's to go with those reactions, like that. Sometimes they give you 3, sometimes they give you 4. Anyway, we'll stick with 2 for today. Okay? So, we need to now think to ourselves, do we perhaps need to flip one of these equations so that when we add them, it's on the correct side in the end? Does that make sense? So, what do I want? I want iron and oxygen on the left, and I want iron oxide on the right. Everybody okay with that? And so the first equation that was given to us, we have a problem. The iron oxide is on the left. And when I add it up, it's going to end up being, well, a reactant instead of a product. And I don't want that. So I'm going to need to, like you do for decomposition versus formation, they're flipped, right? All I'm going to do is you can flip any reaction. So I'm going to flip this one. And just like we did for formation and decomposition, when we flipped the reaction, what did we do with the delta H value? It was also flipped. The sign was flipped. Same thing. So what I'm going to do is I'm going to write down this flipped. So I'm going to write down 2 irons first, and then 3 carbon dioxides, and then my arrow, and then my Fe2O3 and my 3 COs. And right away, I'm going to write down my delta H is equal to now positive 26.74 kilojoules. Okay? What about this guy? Do I need to flip it? What's it got in it that's the same as the one above? Carbon monoxide? No. Oxygen. Ah, yeah, oxygen. Oxygen, oxygen. Okay, so am I going to flip it? No, because the oxygen is on the left, and I want it on the left, and so I leave it. If it is, and I want, you leave it. So I'm going to write carbon monoxide plus half of an oxygen yields carbon dioxide. And the delta H for that is negative 282.96 kilojoules. Everybody okay so far? So the first thing you do is you look for flips. And you look for those flips based on what side do I want it on, and is it there yet? No? Okay, flip it. Yes? Okay, leave it. Everybody all right with that? The second, so the first is flip. That's the first thing we're looking for. The second thing we're looking for are multiplies. In this example here, I want 2 irons. And I want 1 Fe2O3. This formula has it. 2 irons, 1 Fe2O3. So we don't multiply this one. And by multiply, I mean multiply or divide, by the way. Or multiply by half, whatever. Carbon monoxide. Oxygen. Oh yeah, it was the oxygen, right? How many oxygens do I want? In my question that I'm looking for, right? This one. 1.5. How many have I got? Only a half. Can I get oxygen from anywhere else? No, this is the sole provider of the oxygen. So I don't just want a half, I want 3 halves. So in order to get this to be 3 halves, I need to do what to it? Multiply by 3. So I want 3 halves of these, just like the question. Then that means I multiply this by 3 and multiply this by 3. So I've multiplied everything by 3, or I've taken 3 of these. Okay? Gabby, you must be engaged with the material. If I take 3 of these, let me just rephrase that. If 1 carbon dioxide produced gave me 282 kilojoules, then 3 carbon dioxides produced will give me, well, like the easy, 3 times that. This was part of chapter 9, right? So times that by 3. So if I decide I need this multiplied by 3, I multiply this by 3, this by 3, this by 3. Oh yeah, and that by 3. Multiply every single term all the way across, including the delta H. Okay? Now, I have flipped everything so that it's on the correct side. I have multiplied everything so that I have this right amount. Now, I should be done. To double check to make sure I've done it correctly, I then do the algebra. So I'm hoping you can see by now, but maybe you can't. You might want to, especially when it gets complicated, you get about 4 of these reactions, you might want to write it all down. But I'm hoping that you can see up here, I have 3 CO2s going to cancel out, 3 COs going to cancel out 3 COs. Can you see that right off the bat a little bit? And can you see that something else cancels? My carbon dioxides. And so I'm left with iron, that's cancelled, that one. Arrows, so iron, and 3 halves and O2. Arrows, that's cancelled, and that one. So that's my sum of those 2 reactions. Is it the same as what I'm looking for? Yes? Great. That means I've done it right. I flipped the things I was supposed to flip, and I multiplied the things I was supposed to multiply. Which means I can just go ahead now and actually type that in my calculator. Positive 26.9 plus 3 of those. Okay, and your final delta H ends up being negative 822, and it's exothermic because it ended up with a negative value. Okay? Makes sense? Sort of? So you first flip so that everything's on the correct side. You then multiply so you have the correct number of here. You then might just need to look to see if the cancelling out is going to work out when it gets a bit trickier. You might need to flip or multiply different things in order for that to happen. You'll see. And then you add them. Okay? Oh, and then we need to remember states. This gets really important on the next sheet. Okay, so what's the state of matter for Fe? Solid. What's the state of matter for O2?
Yes.
What's the state of matter for Fe2O3? It's always stumps students. What kind of compound is it? Ionic. Ionic compounds are always solid. That's why we call them salts. Okay, so they're always solid unless, this is the only time they're not solid, well, unless you melt it, but at room temperature and pressure. They're always solid unless you've got an aqueous environment or water produced, or you've got water somewhere. I don't have water produced. These aren't aqueous, so it might be soluble, but I don't care because it's got nothing to dissolve into. So therefore it has to be solid. If it was aqueous, this might be aqueous or it might be a solid precipitate. Okay? But for now, no water around, has to be solid. Okay? Okay, so you have another sheet. Looks like this. Go back to your, flip on your next package, or flip to the next page in your package. There it is. Okay, we're going to do question 1 together. 2, I'll let you do, I'll say go and do it in 5 minutes, and I'll do it on the board as soon as you've had a little trial. And then we'll see how we're doing after that, and see if I need to still walk you through or if you're going to be okay to do it together. Okay, so question 1, here it is. That's what it's asking for. What is the delta H for this? Here are the things it gives me. Here are the delta H's that belongs with those reactions. Okay? What's the first thing we do? Flip. How do I decide if we flip? Yeah. Look to see if it's the same size. So I want, in this equation, what's in here that's like my star pupil? That's probably not anywhere else. My C2H4. The rest are pretty common. I probably have oxygen somewhere else, and I probably have water somewhere else. So C2H4 is the star pupil in that reaction. Everybody get that? C2H4 is on the left-hand side of this arrow, yes? Is it on the left-hand side of that arrow?
Yeah.
So am I going to flip this one? Correct, I leave it. So I'm leaving this as is. And do you know what? I'm just going to write it out, because otherwise it gets a bit, if I write it here, is the thing going to see? need to end here probably. Okay, so I'm going to write it out on your page somewhere. C2H4 gas plus 3 O2 gases yields 2 CO2. Gabby, you're writing this down. Gases plus 2 H2O liquids. An H2O liquid can only cancel out another H2O liquid. An H2O liquid cannot cancel out an H2O gas. Got it? Because they have different bond energies. Remember we talked about that a couple weeks, well, maybe a week ago. And that's important towards the end here, okay? Okay, and the delta H stays as is. Because we haven't flipped it, we haven't multiplied. Do we need to multiply that one? No, why?
Because it's a 1 in front of each C2H4.
Right, there's a 1 C2H4 here and a 1 C2H4 here, so probably we're good to go. Okay, what about this one? C2, what's our star pupil in this one? C2H6. Where is it? Over here. Oh no, on the other side of the arrow.
Oh no.
What do I need to do?
Flip it.
Flip it. So I'm going to write down 2 CO2 gases plus 3 H2O liquids goes to C2H6 gas and 3 halves of an O2. Gabby, you must either be really fast at writing or you're still not engaging in the lesson. If I flip the symbols, I need to flip the sign on the delta H. So right away, otherwise I will forget, I'm going to put that in, plus. What do you think I need to do with the last one? Probably stays the same. Do I need to multiply it? Nope, probably not. So I'm going to write down, and let me tell you something, H2 gas plus half an O2 gas. It's always really helpful if our arrows pretty much line up, if not exactly line up. H2O liquid. If I've done it all right, I should be able to cancel and end up with the reaction I'm looking for. So, who can see cancellation and which one do you see?
H2O, all the H2Os will cancel.
All the H2Os cancel?
Yeah, because the 3 there goes to the 2.
1, 2, 3 waters, 2 waters, 1 water. 3 waters on the left and 3 waters total on the right. So that's true.
The 2 CO2s.
2 CO2s. 1, 2, 1, 2. Yes?
Me and Graham have to go now.
Okay, good luck on your match on your game.
Thank you.
Pardon? Oxygens? Boys, your homework would be to do like 2 of these, if not 3.
I'll be
Okay? Or, yeah, 3. The other sheet's easier, but if you find yourself really struggling, go to the next sheet and try 3 of those ones instead. Okay?
3 O2 at the top and the O2 at the bottom.
Right, so we can see oxygen on both sides, right? 3 oxygens, and a half, and 3 and a half. 1, 2, 3 and a half. 1, 2, 3 and a half.
That's it.
And that's it. What am I left with? C2H4. Oh, I'm going to have to write that over there. C2H4, H2, nothing, arrow, C2H6, nothing.
Good luck, guys. Good luck.
And tappity tap in your calculator.
Negative 125.
Negative 1400, positive 1500, leaves with positive 100. Negative 285, so I've got about a negative 180 here.
Negative 136.8.
Negative 136.8 kilojoules. And since I'm adding these delta H's, what are my significant figures then for the delta H? How would you answer with proper significant digits? You would look at the decimal places. What's my least number of decimal places? 0. This guy doesn't have any. This guy doesn't have any. This guy's 1. So my answer can't have any decimal places. So with significant digits, I have negative 137 kilojoules. Okay? So you flip and multiply based on the reaction you're heading towards. Okay? Then you look for cancellations. You might need to do a bit more flipping or a bit more addition. Multiplication, I mean. But by the way, multiplication can also be division. We're going to run into that. And then you add it all up and you should end up with the right answer. Okay? So, have a go on your own for question 2. And I'll give you like 4 or 5 minutes to work on it, and then I will help you by doing it.